Connecting mathematics to life, using modeling, problem solving, and authentic learning to foster engagement, fluency, and quantitative literacy. This presentation is designed for educators who may be working with students who demonstrate low engagement, limited interest, or challenges with critical thinking and problem solving. The presentation focuses on the concept of meaningful learning experiences. Throughout the presentation, we will explore what makes learning meaningful, how educators can design meaningful learning experiences, and why meaningful learning matters for students' engagement, understanding, and long-term success. Some key questions to ask yourself before continuing with this presentation. How can meaningful mathematics learning experiences foster engagement, mathematical fluency, and quantitative literacy? How can educators design learning experiences that help students see the relevance of mathematics in their daily lives? How can authentic mathematical experiences transform students from passive learners into confident problem solvers? Meaningful mathematics learning begins with understanding students as individuals. Research suggests that students learn best when they feel safe, supported, and connected to their teachers. By building positive relationships, teachers gain insight into students' interest, cultural background, personal goals, prior knowledge, and learning needs. This understanding allows teachers to design learning experiences that are relevant, accessible, and appropriately challenging. When mathematical concepts are connected to students' experiences and prior knowledge through authentic context, students are more likely to see the relevance of mathematics, engage with learning, and develop positive mathematical dispositions. Once we understand what meaningful mathematics learning looks like, we can begin to rethink the purpose of mathematics education. Is mathematical fluency and proficiency enough? Mathematical fluency refers to students' ability to accurately, efficiently, and flexibly perform calculations and procedures. Mathematical proficiency is a broader concept that includes conceptual understanding, procedural fluency, strategy competence, adaptive reasoning, and productive disposition. A mathematically proficient student can understand concepts, reason logically, solve problems strategically, and perform calculations accurately. However, mathematical proficiency does not necessarily guarantee that students can apply mathematics beyond the classroom. Students may succeed on traditional assessment, yet struggle to use mathematical reasoning in everyday situations. This is where quantitative literacy becomes important. Quantitative literacy extends beyond mathematical proficiency by emphasizing the ability to apply mathematical knowledge and reasoning in authentic contexts. It requires students to interpret information, make informed decisions, transfer their learning across the situations, and communicate their thinking effectively. To develop quantitative literacy, students need opportunities to engage with meaningful learning experiences and authentic problems. By helping students see the relevance of mathematics in their daily lives, educators can prepare them to use mathematics confidently both in and beyond the classroom. To design learning experiences that develop quantitative literacy, we need to consider how instruction can intentionally connect learning outcomes with authentic mathematical engagement. Here is a simple modified mathematics learning experience for students with significant gaps in prior knowledge and mathematical skills. The focus is on strengthening foundational understanding while building meaningful connections to authentic, real-world contact. The curriculum is designed around three key principles: engagement, mathematical fluency, and integrative thinking. Learning experiences emphasize interdisciplinary connections, real-world applications, and career relevance, while also supporting teachers with guiding questions that promote explicit connections between concepts. This approach aligns with research on quantitative literacy, quantitative reasoning, and integrative thinking, which emphasizes the interpretation, communication, and application of mathematical ideas in authentic contexts. Through problem-based and project-based learning, students are supported in developing both foundational skills and the habits of mind needed to work with quantitative information across context. Over time, this type of learning experience helps students move beyond procedural questions such as, when will I use this, toward a deeper recognition that mathematics is already present in everyday life and decision-making. To support the implementation of a curriculum designed to promote engagement, inclusivity, and integrative thinking, it is essential to align assessment practice with these same goals. In this approach, assessment is not only used to evaluate learning, but also to inform instruction and support ongoing students' development. A sample rubric is used for a cross-domain mathematics project in which students take on the role of an interior designer tasked with designing an inclusive classroom within given constraints. Throughout the task, students are expected to identify and apply relevant mathematical concepts, communicate their reasoning, and connect their work to real-world consideration. The rubric is structured around four dimensions: mathematical knowledge and connections, authentic applications of mathematics, mathematical communication, and reflection and decision-making. Together, these dimensions emphasize students' ability to integrate mathematical understanding across context, rather than focus solely on procedural accuracy. This approach aligns with research on formative assessment and authentic mathematical thinking, which highlights the importance of evaluating not only what students know, but how they apply, communicate, and reflect on their mathematical reasoning. Formative assessment practices are particularly powerful in this context because they provide ongoing evidence of students' thinking, allowing teachers to identify misconceptions, adjust instruction, and support deeper understanding during learning process. Rather than serving only a summative evaluation tool, the rubric functions as a guide for learning. It supports timely feedback, promotes students' self-awareness of their thinking, and helps develop critical thinking, problem-solving, and decision-making skills. In this way, assessment becomes an integral part of meaningful mathematical learning rather than a separate endpoint. Throughout this presentation, we have looked at what meaningful mathematics learning can look like, how educators can design meaningful learning experiences, and how these experiences can impact students' engagement, fluency, and quantitative literacy. So, what is the next step? One starting point is to reflect on what we already know about our student. Do we understand their background, interest, proficiency levels, prior knowledge, and specific learning needs? Do we know what helps them feel safe, supported, and willing to participate in mathematics learning? Another step is to review the learning environment. Is the classroom safe, welcoming, and accessible for all students? Are students encouraged to take risks, ask questions, and explain their thinking? Educators can also review their curriculum and daily lessons by asking, what is the learning outcome? Are students only practicing procedures, or are they also developing conceptual understanding, critical thinking, and problem-solving skills? Do they have opportunities to make meaningful connections, transfer their learning across contexts, and communicate their mathematical reasoning? Assessment is another important area for reflection. What is the purpose of each assessment opportunity? How is evidence of students' thinking collected? More importantly, how is that information used to provide feedback, adjust instruction, and support students' growth? Meaningful mathematics learning is not created by one activity or one project. It is created through intentional instructional design. Authentic learning experiences encourage students to examine their current understanding, apply higher order thinking, justify their reasoning, and consider multiple perspectives. Through this process, students are not only learning mathematical content, they are also developing habits of mind that help them think critically, creatively, and integratively. When students engage in modeling, problem solving, and authentic learning, mathematics become more than a set of isolated procedures. It becomes a tool for understanding and navigating the world around them. By connecting mathematics to life, educators can foster engagement, strengthen mathematical fluency, and support the development of quantitative literacy.